All right, another example from section 9.4. We're going to go work ourselves through number 7 this time. The equation that we start with here on number 7 is xy minus 4x minus 2y is equal to 0. Again, we have to start by finding the angle of rotation. Please notice in the equation, though, there's no x squared, no y squared term, neither an x squared nor a y squared. Therefore, the a value is 0, the c value is 0, and the b value, the number in front of the xy term, is 1. So when we do the simplifying, of course, very easy, we get 0. What angle gives us a cotangent of 0? That's 90 degrees. And when we divide both sides by 2, that means our angle of rotation then is going to be 45. All right? Now, excuse me. When we know the angle of rotation is 45, then everywhere we see an x, we're going to be able to then replace that with x prime cosine of 45 minus y prime sine of 45. And everywhere we see a y, we get to replace that with x prime sine of 45 plus y prime cosine of 45. And when we simplify the trig values using our trig sheet, the cosine of 45 is the square root of 2 over 2. The sine of 45 is the square root of 2 over 2. So we get to insert those several times. And you can see the only difference between what we're going to replace x and y with will be the plus or minus that's in the middle. All right, that's all that's really different at all. Okay, so again, now we'll drop down our equation like we have been and make our substitution. So here's our original equation, and we'll make our substitutions. All right, so everywhere we see an x, the square root of 2 over 2x prime minus the square root of 2 over 2y primed. Everywhere we see a y, same thing except a plus in the middle. All right, so there's our x times y. Then minus 4 times the x. And finally, minus 2 times the y. All right. So not nearly as much simplifying here as we've had on some of our other problems. We only have one FOIL to worry about, and the FOIL isn't quite so bad because these two fellows to start with are conjugates of each other. They're exactly the same binomial except one has a plus in the middle, one has a minus in the middle. So when you think about doing a FOIL with conjugates, the O and the I always cancel each other out. So all you have to really worry about is the firsts. Square root of 2 over 2 times the square root of 2 over 2, so that's going to be 1/2 x prime squared. And then the lasts. Negative square root of 2 over 2 times positive square root of 2 over 2 is going to be negative 1/2 y primed squared. All right, then a little distributive action here. Distributing the negative 4 would then give us negative 2 square roots of 2x prime plus 2 square roots of 2 y prime. All right, and distributing a negative 2. The 2's just cancel, so I'd have the square root of 2x prime, and the 2's just cancel, giving me a negative square root of 2y prime is equal to 0. A couple of like terms that I have to put together. I've got x primes and x primes, so negative 2 square roots of 2 and negative 1 square root of 2 would then make that negative 3 square roots of 2x prime. And then the y primes, positive 2 square roots of 2 and negative 1 square root of 2 would leave me with positive 1 square root of 2 y primed. All right, and I'm just going to double check to make sure that looks okay. Minus and plus. Yep, that looks good. Okay. Now, what's different about this one, at least if you've been watching the videos that are following along with the examples, is here's an example of an equation now that we've done the change of variable, where first we can tell what shape it is. All right, we have two squared terms. Okay, there's our x prime squared, and here's our y prime squared. And please notice that the numbers in front have different signs. One is positive, and the other is negative. So when the squared terms have different signs, that means we're going to have a hyperbola, right? But what's going on here is we also have a x primed and y primed term. And so what we're going to have to do is complete the square. We're going to have to complete the square to find the center of this hyperbola. All right? Now, the fractions are going to make this a little bit tough. So what I'm going to ask you guys to do right now, at this step, if you're following along, is get rid of the fractions by multiplying everything through by 2. Right? That just gets rid of the fractions. So 2 times a half would just be x prime squared. 2 times negative a half would just be negative y prime squared. 2 times negative 3 would be negative 6, square roots of 2 x prime. And 2 times 1 would be 2, square roots of 2 y primed. 0 times 2, of course, is just 0. All right, and now to complete the square, we need to get the x primes together. So we put the x prime squared and the negative 6 square roots of 2 x prime together. Okay? And then we put the y's together. So we put the negative y prime squared together with the 2 square roots of 2 y primed. Now I know I'm going to need to complete the square, so I need to add a blank on both sides so I can complete the square for the x's. I'm also going to need to complete the square for the y's, so I need to add a second blank on both sides. Now the number in front of the x's is a positive 1, so that means we can complete the square right away. We can go directly to completing the square. All right, now remember the first term is the variable of above, so that's going to be our x primes. And our second term we get by taking the number sitting in front of the x prime and dividing by 2. So negative 6 square roots of 2 divided by 2. Negative 6 divided by 2 would be negative 3 square roots of 2. But whatever number goes in the parentheses, we have to square, so 3 times 3. The square root of 2 times the square root of 2. And so that gives us an 18. That way we have to back up and add in the blank on both sides. All right? Now we can't complete the square for the y's right off the bat because right now there's a negative sitting in front of the y's. So what I have to do is take an extra step that I didn't have to take here with the x's, but I have to take an extra step here and factor the negative out. So factor the negative out of the y prime squareds, the y primes to the first, and then again, we don't know what that third term is, so we have to leave it as a blank temporarily. But now I can complete the square for the y primes. So now I can complete the square. The first term is the variable above. The second term we get by taking the number in front of the y primed and divide by 2. So negative 2 square roots of 2 divided by 2 would be negative 1 square root of 2. But whatever number goes in the parentheses, we have to square. So the square root of 2 times the square root of 2 is 2. Back up and add in the blank. And then to figure out what goes on the blank on both sides, we have to redistribute the negative 1, which means we need to add a negative 2 in the second blank on both sides. And then to finish this off, we add the 3 numbers on the right-hand side together. Okay? Now it's not quite in standard form because we don't have the number 1 on the right-hand side, so we have to get the 1, dividing everything by 16. I guess I could have made that division line bigger. All right, so that on the right-hand side, 16 divided by 16 is 1. And on the left-hand side, there's no canceling that really happens, so we just have x prime minus 3 square roots of 2 quantity squared over 16 minus y primed minus the square root of 2 quantity squared over 16 is equal to 1. And now we're in standard form. All right, now just to help ourselves out a little bit, I know I've said before when you guys went through sections 1, 2, and 3, all right, we were all, I was forcing you to go through and find all of the different points and information for one of our shapes. But when we got to section 4, I said all I need you to do is graph it. But this is one of the problems where you kind of need to know where the center of this fella is. And so the center of this hyperbola is going to be at positive 3 square roots of 2, comma, positive square root of 2. And remember now, that's again going to be on the x prime, y primed axis. Okay? And just to get you a ballpark for that, that's going to be approximately 4.2, comma, 1.4. So that'll be a little bit helpful when we start drawing our picture to have decimal approximations of where we need to be. Okay? So what we start with is our regular XY coordinate system. And let's see, let's just get the best one I can out here. All right, so let's go. Here's our original X. Y axis. And this time I'm going to change colors a little bit so that I can do this a little better. Now we need to make our angle of rotation 45 degrees. I'm just doing the best I can. I'm going to make that in blue. So that's going to then become my x primed axis. And my y primed is going to be something like that. Okay? Now I'm just using a ruler, and I'm going to put some tick marks on here to help myself out with the two axes so I can get a decent feel for this. So I'm going to go 1, 2, 3, 4, 5, 7. Let's see, that should be enough. How far do I have to go that way? Well, I'll put up a couple in. I'm not sure how far I need to go. Not very far, I don't think. So it should be okay there. And then I'll use the same scale. On the y primed axis. If anything, I might have to go up just a couple more. So I'm just going to go up just a couple. That should be good, I think. All right. So now my center for my hyperbola is approximately 4.2 to the right and 1.4 up. But again, please remember, this is on the x primed, y primed axis. So right 4.2 and up 1.4 is going to put the center of my hyperbola right about there. Just doing the best I can to ballpark it in there. Okay? Then what we need to do is then take the numbers under the x's, which is a 16, and take the square root. The square root of 16 is 4. So that means I'm going to have to go 4 to the right. 1, 2, 3, 4. And 4 to the left. 1, 2, 3, 4. Okay? Then the number under the y's is also a 16. So the square root of 16 again is 4. So I'd have to go up 1, 2, 3, 4. And down, let's see where I'm at. 1, 2, 3, 4. And then through those 4 marks, we're going to try putting in our rectangle. I wonder if I could do this freehand pretty decently at all. Let's give it a try. All right, and then through the rectangle, we're going to draw our extended diagonals. Again, just doing the best I can. So, sorry if those don't look great, but those are supposed to be my extended diagonals. And then finally, let's change colors so you can really see where the hyperbola is going to be drawn. In what direction does this hyperbola open? Well, it's the x primes that are the positive variables. So that means this has to open in the direction of the x prime axis. So this is going to be a hyperbola that starts on the, not once we've rotated it, the right side of the box, rectangle, using the extended diagonals as asymptotes. So the curve is going to look something like this, going in one direction. And then using on the other side of the box, the left side of the box, again in terms of the x primed axis, using the extended asymptotes, so this way and this way. So that's a pretty good representation for the curve that we would get in this case. All right? So like I mentioned on a previous video, let me know if you guys have more worries that you'd like to do, or you'd like me to do. Of course, always ask questions. But this is a pretty tough one. This was a pretty tough one because we also had added the element of needing to complete this square. All right? So good luck with everything and hope you're having some fun. Talk to you soon.